Hello viewers and welcome to Kunyilamadi Smart Clinic with your tutor Sarpa Sport Kunyilamadi Sandy. In today's lesson, I want us to look at this linear algebra question wherein we are asked to find the inverse of what? A, which is equals to this matrix. But I'm going to be using a little bit of an advanced method which we call the Caley-Hamilton theorem. So using the Caley-Hamilton theorem, Caley-Hamilton theorem. The theorem states that every square matrix satisfies its own characteristics polynomial. To use this Caley-Hamilton theorem, we are going to take this matrix A minus some constant, let's say lambda, multiplied by an identity matrix. The determinant of it should be equals to 0. Right? So just follow keenly as we solve. So the determinant of matrix A, which is going to be 2, okay, let's just take it like this, 2, 3, 1, 2, let's say this is inside the bracket, minus lambda. A 2 by 2 identity matrix is going to be 1, 0, and this is 0, 1. This is what? 2 by 2 identity matrix. So we are going to have 2, 3, 1, 2 minus lambda times 1 is lambda, lambda times 0 is 0, lambda by this 0 here is 0, and lambda by this other one is lambda. So, but don't forget, at the end of the day, we should find what? We say the determinant should be 0, We should find a determinant. So, 2 minus lambda, then 1 minus 0 is 1, and 3 minus 0 is 3, and 2 minus this other lambda is 2 minus lambda. So, we say the determinant should be equals to 0. So now to find the determinant of this matrix, you multiply what? The leading diagonals. So 2 minus lambda into 2 minus lambda minus 1 times 3. Everything should be equals to 0. So now let's expand this one. 2 times 2 is 4 minus 2 times lambda is 2 lambda minus lambda times 2 is 2 lambda again, minus minus is plus, and lambda times lambda is lambda squared, minus 3 times 1 is 3. Everything should be equals to 0. So at this point, we collect like terms by saying 4 minus 3 is 1, minus 2 lambda is minus 4 lambda plus lambda square. Everything should be equals to 0. So we want to rearrange this equation. So we take lambda square minus 4 lambda plus 1. We said everything should be equals to 0. Now we are going to replace lambda with the matrix A. So if you say lambda, you now say A squared minus 4A plus 1 is identity, right? So the identity matrix equals to 0. So we want to find A inverse. So what are we going to do? We multiply 12 by what? A inverse. So multiply by A inverse throughout. So this expression here is going to give us A to the power 2 times A inverse minus 4A times A inverse plus I times A inverse. So what is going to happen? A times A, according to the multiplication law, we take one of the A's. That you say 2 minus 1 is 1, So this is A. And there, this is 1. So 1 minus 1 is 0. So A to the power 0 is 1, So we are left with what? 4I. That is the identity. So plus identity here is we say is what? 1. So 1 times A inverse is the same as what? A inverse. So let's wipe this part off. So at this point, we now rearrange. We say this should be equals to 0. So rearranging it, we are going to have A minus 4I plus A inverse equals to 0. So A inverse is going to remain where it is. It should be equals to what? This minus 4, when it goes over, it becomes what? Plus 4I. Then this plus A becomes minus A. So the inverse of this matrix is going to be 4. Identity matrix under 2 by 2 says like this. Then the matrix A inverse is going to give us 4 times 1 is 4, 0, 0, 4. Minus the 2 by 2 matrix 2, 1, 3, 2. So A inverse is finally going to give us 4 minus 2. 2, 0 minus 1 minus 1, and 0 minus 3 is minus 3, and 4 minus 2 here is 2. So this is the inverse of what? A. So this method is what? Is quite advanced for those who are in universities. You can adopt this method to what? To find the inverse of what? A 2 by 2 matrix, 3 by 3, as the case may be. So thanks for watching. Make sure you like this video, you share it with your friends and classmates, then you subscribe to the channel and turn on the notifications, so whenever lessons are dropped, you'll be updated. Thanks for watching.